a 4-pound ball B is traveling around a circle of radius 3 feet with a speed of 6 feet per second. If the attached card is pulled down through the hole with a constant speed of 2 feet per second, determine the ball's speed when the radius is 2 feet and how much work has been done to pull down the cord. Neglect the friction and size of the ball. So because the ball is spinning at speed of 6 feet per second and it's pulled down, so clearly this radius is going to decrease. We're going to find the velocity of the ball when the radius is 2 feet. And of course, the work done to move the ball from 3 feet to 2 feet. Okay. Okay, so let's start to think of this in terms of principle of angular impulse and momentum. The principle of angular impulse and momentum states that HO1 plus the external torque or external force, well, we're going to take the external moment from T1 to T2 equals H02, right? So we need to find, we do know this, we know the initial momentum, it's going to be R, the radius, times mass times velocity. We do not know this. So if we can find m0 dt, then we should be able to compute h02, right? So 1 indicates the instance when the radius is 3 feet, 2 denotes the instance when the radius is 2 feet. Now, what are the external forces on the particle? So if you draw an FPD, you can figure out the external forces. So there's going to be a force which is pulling the particle inwards. There's going to be gravity which is going to act downwards. Is there any other force? There's no friction, so there's no force. Otherwise, there'll be a friction force in the direction which is opposing the motion, right? It's moving this way. Okay, so this will help us to find the moment. What's the moment? The moment is R cross F. R cross F. Let me put Ri, Fi. So each force, this force, I need to find R, the radius, times, the distance from O to point B, crossed with F. Now, R is this length. F is acting along the length. Since those two vectors are parallel, the cross product is going to be 0, right? Because this force passes through the center of the circle. This is the center of the circle. So this is going to be 0 for that force. We are only interested in planar motion. We are only interested in motion in this plane. So really, it doesn't make sense for me to put mg because mg doesn't contribute to the motion in that plane. So the only force is actually F. So since this force is 0, turns out that H01 equals H02. Or in other words, this is conservation of angular momentum, right? Although we started with principle of angular impulse and momentum, it reduced to conservation of momentum because the net external moment is 0. So now we can solve for the velocity. Initial momentum is r cross mv, but r is this way, velocity is that way. So the cross product is going to be sine of 90, which is 1. So I'm just going to write it as RMV equals R2 mv2. So initial, mass cancels off. The initial radius is 3 feet. The initial velocity is 6. Okay, equals the new radius is 2. And the new velocity is unknown. So from this, we can solve for the velocity. Comes out to be 9 feet per second. Okay, so let's try to write the initial velocity. The initial velocity is what? Is 6 feet per second, right? It's 6 feet per second in the tangential direction, and it is 2 feet per second in the radial direction. Is that right? Okay. Well, we're going to assume that initially the ball is not being pulled by the force, or is not pulled with the uniform speed of 2 feet per second. So initial velocity is only tangential. Okay. So a good coordinate system for this is not x, y, because it's moving in circles. It's either n, t, or r theta. Okay. Both of those coordinate systems will do, because if things move in circle, then you can use either of those two. Let's just use ER E theta. So the initial speed is 6 times E theta. Where this is E theta ER. Is that right? Should ER point this way or the other way? Which direction is ER? Is it this way or this way? I think it's outwards, right? Is that right? Okay, so it's going to be 6 times E theta, because velocity is along theta, and velocity 2, this is just the magnitude, and this is only in the tangential direction, is 9 times in the E theta direction, right? And it's going to be 2 times in the negative ER direction, because it's going to be, this particle is pulled down with a speed of 2 feet per second, the same speed as this. So it's going to have a radial component pointing in the opposite direction. So this is the speed. In order to solve for the work done, what I'll do is, one way of finding the work done is find all the forces acting on the particle and then do F dot dr, right? Which means I'll have to first find this force, then find the change in R, and that will give me the magnitude of the work done. Okay? In order to find a force, I'll have to use equations of motion. Okay? So in order to do all those steps, first find F, then find the work done, I can actually take a shortcut by not using F equals ma, but using principle of energy and work done. So principle of work and energy states that, and this is going 2 chapters back, right? Principle of work energy states that is the initial kinetic energy plus the work done in going from 1 to 2 equals the new kinetic energy. So this is what I'm after. And the good news is I have the initial kinetic energy, I have the final kinetic energy, because I know the velocity. So half m v1 square, so that's going to be 6 square. Let me just write the mass as a numerical value. So mass is 4 pounds, so 4 divided by 32.2 times 6 square plus u12 is the unknown equals half times the mass, which is 4 divided by 32.2 times the velocity, but the velocity is 9 square plus 2 square or minus 2 square. So solving this gives me u12 equals work done, which equals 3.04 feet-pound. So this is sort of a shortcut for solving the problem. I don't really compute F. I get it. Since I've been asked to find the work done, I use this principle very cleverly. I do not solve for F. So that would have been 2 steps. First use F equals ma and then find the work done. But this way, it's just 1 step using principle of work and energy.
What is that velocity on square root?
Absolutely. Squared. Okay, any questions? Okay, let's solve another problem with this same principle. So 2 blocks A and B each have a mass of 400 grams. The blocks are fixed to the horizontal rods and the initial velocity along the circular path is 2 meters per second. So this velocity is 2 meters per second. If a couple moment m equals 0.6 Newton meters is applied about CD of the frame, determine the speed of the block when time t is 3 seconds. The mass of the frame is negligible and it is free to rotate about CD. Neglect the size of the blocks. Okay, so this thing is spinning at 2 meters per second. Then a force or a torque with a moment of 0.6 Newton meters applied for 3 seconds. You're going to find the new velocity of the system. Okay, so again, this particular chapter, the key thing to note in the questions is you will be asked to find speed as a function of time. Find speed when the time is given, or vice versa. You'll be given the speed and told to find the time. If you see that, then you're better off using either linear momentum and impulse or angular momentum and impulse. Since this is spinning in circles, you're better off using a principle of angular momentum and impulse. If this question was find the speed when the angle turned is 30 degrees or 40 degrees, then speed is a function of displacement, and you'll use principle of work energy, not this chapter, but 2 chapters back, right? That's a cue to use this principle. Again, this can be solved using F equals ma, absolutely fine, but it's shorter to use principle of angular momentum and impulse. So let's use that. So principle of angular and impulse. Okay, which states that the initial momentum plus m dt equals the new angular momentum. Again, you're better off drawing a free body diagram. So let's draw a free body diagram of this system. Okay, I'm just going to break this system off at this and this joint. So there'll probably be a reaction force like this. Okay, R is the reaction force here, another reaction force over here. Okay, so you could write it this way. You could also write Rx, Ry, Rz if you like. I just wrote it as a vector, so it's a vector which has a direction. It's really, you'll see in this problem, it really doesn't matter. Those will not show up in the equation when I do the calculation. So when I do the calculation, I'm going to take moments about the axis O, and when I take moments about axis O, since R passes through the axis O, and R1 and R2 pass through the axis of O, they do not contribute to m dt. So let's try to set up this equation now. The initial momentum is R cross mv, where let's call this m, this is v, let's call this v1, and this is r, right? So mv1 is the momentum for one of the blocks. Since there are two blocks, it's going to be twice. Okay. Uh, the next part is the external moment. Well, all the moments acting on the system of auto. R1, R2 pass through, so the contribution to the moments to those is zero. The only thing which leads to a non-zero moment is the external moment m, which is 0.6, and it's a constant, so it's very easy to integrate that. So T2 to T1 equals the new momentum, which is R cross mv2, and since there are two of those, it's going to be twice. Okay, so 2 times the radius is 0.3 times mass is 400 grams, so 0.4 kgs. Velocity is 2 plus 0.6. Delta t is 3 seconds. This is delta t, which is 3, equals 2 times 0.3 times 0.4 times v2. Okay, so in that equation, the only unknown is v2, and we can solve for v2. So solving, v2 equals 9.5 meters per second. Okay. Any If the rod of negligible mass is subjected to a couple moment m, 30t square, and the engine of the car supplies a traction force of 15t newtons to the wheels, where t is in seconds, determine the speed of the car at the instance when t is 5 seconds. The car starts from rest, and the total mass of the car and rider is 150 kilograms. Okay, so when you read this question, a couple of things stick out, which is you're told to find the speed of the car when the time is 5 seconds. So again, you're asked to find v as a function of t. When you see v as a function of t, I would recommend using either linear impulse and momentum or angular impulse and momentum. Okay, things are spinning in circles here, so you're better off using angular impulse and momentum. Right, so once you make that decision, it's quite easy to solve this problem. So I'm going to write that down so you have that when you're refreshing your notes. Okay, so principle of angular which states that h01 plus t1 t2 m0 dt equals the new momentum. Okay, so let me draw a free body diagram, because that will help me to find mo. So it's a free body diagram of the rider and the car, which is the front of the particle, the rod, and I'm going to break it up here. So there'll be a force, external force here. So if you like, you can put reaction force in the E theta direction, reaction from the R direction. There is a force acting this fashion, it's 15t, and there's a moment 30t square. Okay, there is no friction, so if there was friction, you'd show it in this direction, opposing motion. But since there's no friction, you don't have to worry about it. Okay, is there any other force I'm missing? Okay, there's mg downwards, but really it doesn't matter here because we're only interested in motion in the r theta plane. Okay, so let's try to sub in here. h0 is the initial momentum, is simply 0 because the system starts from rest. Okay, so let's write the moment. There are three forces and there's one moment. So all these things we have to account for when we write the contribution to the moments. Okay, so when we take the moment about O, R and R E theta, we write this as R theta. I have a contribution, I have no contribution because R and R theta act at O, and the moment arm is 0, right? So those two do not contribute. The only things which contribute are going to be the moment, external moment, 30t square will show up as it is. So 30t square dt. I'm going to sub this limits too. So it's 0 to 5. So 0 to 5, 30 t square dt. And then there is a moment due to 15t. So the moment due to 15t is going to act in the same direction as m. Or in other words, if you want to do it using vectors, the vector r is this way. Right? R is this way, F is that way. So R cross F, it's a negative moment. R cross F. R is ER crossed with 15TE theta. So M due to F. So 15T ER E theta is going to be in C ER E theta Z, right? So this is exactly like IJK, except that we'll have, should be K. So ER E theta should be K. Yeah, so it is positive. When you do R cross F, the vector R points this way. So you need to curl your fingers from R to F. So when I curl my fingers from R, because this is the direction of R, to F, F is that way. My thumb gives me the direction of the moment, and that is positive. And here also I see when I do ER E theta, I get K, so it's positive K. So that works well. So this should be 15 T dt equals the momentum. So R cross mv. So let's finish this off. This won't take much time. So this is going to give me 30t cubed divided by 350 plus 15t squared divided by 2, 5 and 0 equals the radius, which is 4 meters. The mass is 150 and the velocity is unknown. If you like, I'll put mv2 here just to denote the velocity after 3 seconds. This comes out to be 1, 2 plus 750 equals 600 V2. So we can solve for V2. It comes out to be 3.33 meters per second. Okay. Any questions on that? Yeah.
Signal if you're taking a moment, you multiply by the radius of the receiver.
Oh yeah. My bad. This should be 4 times 15. I skipped it here too, I think. This should be R. Absolutely right. This should be 60. I think my solution includes the 60, so this is right. The solution is right, except that I forgot to multiply with R. Thanks. Any other question? Okay, so first of all, your homework due date has been extended to coming Sunday. I would recommend just doing it after you're done with the exam. The exam is on Friday, same time, 5:30 to 6:45. It doesn't cover this chapter, it covers the chapter on work energy. So I believe 14 and 18, right? 14 and 18. It'll be the same format as last time, 4 short answer questions and 2 long questions.